top right, what do we need to write?
1-3 postulate.
We're gonna go 1-3 in the top right hand corner, you're gonna write 8, 26, 13. Okay? One, three, postulates. Okay, of course, what's the first thing we need to talk about? What is a postulate?
Statements of geometry that are accepted as true.
Okay with that. Things in geometry. That are accepted to be true. We're gonna write down our postulates from this section. 1-1. 2 points. Determine a unique line. One, two. In other words, there isn't two types of lines you can draw through 2 points. There's only one. If two distinct lines intersect, then their intersection is a what? Point. 1, 3. 3 non-collinear points determine a unique plane. What does unique mean? There's only one of them. If you're unique, there's only one, right? So, through 3 points, you can only draw one plane. Through 2 points, you can only draw one line. And if 2 lines intersect, they have to intersect at a point. Let's go ahead and write 1-4, even though it's later on in the chapter. If two distinct, or later on in the section, if two distinct planes intersect, then their intersection is a what? Line. When planes intersect, they intersect at a line. When lines intersect, they intersect at a
Point.
okay? Helps you with the little lines in between each. Separate. Okay. These are the postulates from this section. What we are going to do, in essence, is apply those concepts. Take a worksheet, hand it around. I want you to do this worksheet with me. This is part of your notes. So please wait until everybody gets this down and we get started. When we're done passing it around, if you can bring it back up there, I'd be appreciative.
Oh, Aubrey. I follow her. That may have been like the best video ever. I followed her. That's how funny she is.
There's no need to talk.
Mr.
What can I do for you?
I was watching the news this weekend, and they was talking about some, you know how they have those, physical science labs? And, out of state, it's like, they said they're gonna stop doing it in some places because, some kid tried to steal a slinky.
Discussion for another time.
Okay, sorry.
Is there any extras?
Did anybody not get one?
Only one, huh? Oh, my class has gotten a lot bigger. Thank you, ma'am. Okay. Let's look at these. Quiet, please. Points A, B, and C are non-collinear. Name all the different lines that can be drawn through these points. What will help you a lot is to draw what? 3 non-collinear points, A, B, C. Now, first of all, what points can I draw? Where can I draw? Or what lines? What does our apostille say? Through any 2 points, there's only one distinct line. So there's one there, correct?
Mm-hmm.
So that would be line what?
AP.
What do you have to put above it?
Line.
Line sign. What about another line? Already did BA.
C, AC.
AC. Remember, they didn't ask how many different ways, they just asked for 3 lines. So as long as we name it correctly, we only have to name it once.
And BC.
Okay, so that would be comma. Whenever you're talking about a bunch of things, you put a comma in between them. AC, what do I have to have above it?
Line.
What's the last one?
Line BC.
Line BC. There's your answer. What is the intersection of LM and LN? Now, and actually the first one you didn't have to draw a picture. This one you don't have to either, but if you'd like to, what would you draw? 2 lines intersecting. One of the lines is LM and the other one's LN. What do you think this point has to be?
L.
Because it's used both what?
Both lines.
In both lines. That's the only way it would work. So which point is the intersection? And remember, they're asking for a point, so your answer should be like a point, which is a capital letter, correct? The next one, they ask us to name all the planes represented. You can work bottom to up. Everybody look up here. The first plane, how about start with the bottom? What's the bottom plane?
BDC.
ADC. I need 3 non-collinear points to name it. So I'm talking about the bottom right there. We've already done that, correct? We gotta do the back now, don't we?
BCA.
BAC.
That's this one right here. That would be ABC. What about here? Now we've done the bottom, the back, I need the right and the left, right?
BCD.
I'm gonna use a different kind of, I'm gonna use X's for these. BDC. And I'll use X's right here again.
ABD.
ABD. I've named all the planes, haven't I?
Yep.
There's not any more. Not too bad, is it? Name the intersection of ONJ and KJI. O to N to J. So which one am I talking about?
The back one.
the back, and the intersection of K, J, I. Now, here's the big problem some of you might run into here. You see intersection, your natural thing is to think of a what? But what are we talking about? Are we talking about two lines here? We're talking about two what? Through any two planes, when they intersect, what is their intersection always going to be? A line. So it's like the edge of a book. You know, each side of a book shares an edge with another side, doesn't it? So the intersection of these two planes here is that edge, isn't it? So what is our edge here?
J.
Right here. Isn't that our edge? So the answer is line KJ. Not KJ, not segment KJ, but line KJ. Name the intersection of KOL and MLH. KOL. So that's the what? That's the side. And MLH. MLH. So that's the front, isn't it? So the side and the front have what in common?
KJ.
No.
Line KJ. I
The
mean
side
KH.
and the front. This corner right, this edge right here, which is what? Name two planes that intersect at MI. So we're talking about this edge right here, and there's only two planes that intersect there. What planes is that an edge of? This side right here, which you could name MNJ, correct? And the front, which you could name MLH maybe. Then you're done. Determine whether a statement is true or false. R, S, and T are collinear. R, S, T, no. False. There is one and only, right now, guys, just look up here with me and I'll let you write it down after we're done. So everybody put your pencils down so you're paying attention, not writing. All pencils down. And look at the picture and try to answer it with me. There's only one plane that contains all the points R, S, and Q. What plane is that? Is there only one plane that contains R, S, and Q?
No.
That is true, actually. Want to know why?
Because only Q's and
3 non-collinear points determine a what?
one. Unique plane.
So if they're non-collinear, there's a chance this is right. R, S, and Q, are they non-collinear? They're not on the same line, so they have to determine only one plane. So that is true. Angle PQT, that's, and we haven't talked about angles, but angle P, then what? Q, and then down here to T, lies in plane N. Is T even inlet plane N?
No.
So what's that gotta be?
False.
SPR lies in plane N. SPR.
No.
Angle. Do all 3 of those points lie in the plane?
Yes.
So that angle has to lie in the plane. X and Y are 2 points on line M. Then XY intersects plane N at P. Or on line M, I'm sorry. That's true, isn't it? Basically, they're saying X and Y here, they're both on line M. And what does line M do? It intersects plane N at P, so that's true. Point K is on plane N. Is point K in this plane?
No.
What do planes do, though? They go on forever and ever? And like in those directions there. So if you were to extend this plane, because this line's in it, is K in it?
Yes.
Actually it is. Does everybody see that? That was a little hard to see. It all lies up here. N contains RS.
Yes.
Is that line inside of it?
Yes.
T lies in N. No, it doesn't. Because it's down here, right? Plane ends up here. R, P, S, and T are coplanar. R, P, S, and T. Which one's not in the same plane?
T.
So that's what? L and M intersect. Do they intersect?
No. No.
Now here's what you gotta see. This one's going down here and this one's staying up here. This one will actually go down here, but it'll never actually touch because it's that way of it. Does that make sense? It's hard, I know it's hard to visualize. You might look at your picture, it doesn't have all the drawings I've got on it. But see, this one keeps coming down here, but never touches this one because it's in front of it. It's in a different plane. So the answer is false.